Suppose 3 months data or 4 months data of the COVID-19, you have seen a flow of different predictions, what were coming out at that time. And also you have experienced that issue that in most of the cases, what has been actually predicted by different experts, that failed. So we have to understand this corresponding issue, that what are the main complexities here and how it was failed and how we can make it successful one. Forget about the issue of this COVID-19. Let us try to focus on the idea of any share market, which is available every time. Try to think of any weather data, anything. So which are dynamical and which are available every time, every day from different corners of the globe. So while we are trying to understand these issues of the data, which are actually being captured every time, which are available every time, continuous flow of these data, we want to make some kind of idea that if some data are available previously, can we understand what should be the results in some of the next days? This is called the idea of the prediction. Now, there is a basic difference between the prediction and estimation. What is the basic difference? In a fine element, we can see that, for example, things what I have said about this COVID-19 data, some days data are available. If the share market data, some days the data are available, and we want to predict or we want to get the idea in future days, what can be the possible answers. This is a prediction. Then what is estimation? For example, suppose a particular company is there. I'm just going away from the healthcare, but that is one practical example here. Suppose a particular company that are trying to launch a four-wheeler or any two-wheeler in the market of a particular brand. So while they are trying to make that one available in the market, so thing is that they just learn what are the available different two-wheelers, different brands of two-wheeler in the market from that particular country. Suppose I'm thinking of India only. So in India, they will try to first rationalize this particular concept, that what are the presently available different brands of two-wheeler there, what are their particular disadvantages and advantages, and what are the prices also. Then they will make the chart. And after that, suppose, let us think that they will just now launch a new particular brand of two-wheeler with this particular facilities. First of all, they will try to analyze that if I try to capture the market properly, what the price I have to set. Say, for example, in a very basic sense, let us suppose that there are available 10 different products inside India with these prices. So what is happening? They want to produce this 11th one. And also we have a comparative analysis. Suppose we have different metro cities, like in Kolkata, like in Delhi, like in Bengaluru, etc. What are the off-road and on-road prices? With these prices, we have the chart. Now we have seen when we are actually having some particular two-wheeler and four-wheeler that is being launched in the market. You have seen every time whether whatever the company is, they actually launch the product in a limited sense. That means, first of all, they have a pilot project. Suppose the first set of products are being launched in one city, say in Chandigarh, say in Mumbai, whatever. After realizing the issues, are the customers getting satisfied properly? What the price we have said, is it okay? Thinking on different particular rationales, then they slowly capture the market in the different provinces of India or whatever the things. This is the issue. So we have to understand this issue is actually being practiced for the case of estimation. That means we do have the data, available data for different metro cities, and they have seen that if this particular metro cities are available with this particular prices, first they provide these in the Chandigarh with a certain price, with one particular pilot price. Then if customers are satisfied with this price, with this particular advantages, what are the things there present in this two-wheeler or four-wheeler, whatever it might be, then they will move to Chandigarh or Chennai or Kolkata, wherever it is, looking at the particular chart, what is available. That means that suppose, for example, let us think of two cities. X is supposed to be Delhi and Y is supposed to be Kolkata. We forget about other cities. So the question is very simply that we have some chart of X and Y. That means Kolkata's price and Delhi's price are given. Now I just have the pilot project in Delhi, saying X. That means if I do have the value of X, looking at the chart, can we learn what should be the possible estimation of Y from that one? This is called estimation. So it means that whenever we have some time-dependent data available, on the basis of that one, we want to predict or we want to just get the analysis in future time. what will be the corresponding values with that trade. That is supposed to be forecasting or prediction. And whenever we have a chart like this in the market study or in some other cases, we have a comparative chart of X and Y or something, maybe more than two variables, 2, 3, 4, whatever it might be. So if I know some of the variables at the final end, and if I want to get the answer of the remaining variable, that question is supposed to be the process of estimation. This is one end of the machine learning, one objective, how to get the comprehension about any estimation procedure or this kind of what is called the forecasting. What is the next one? Next one you can see that is supposed to be here, the classification or clustering. So you have heard this particular previous lecture of Dr. Naman Goel. What he has said that whenever we are having a data, suppose already available data, in certain cases, data are quite leveled. For example, suppose I am thinking of the process here in this particular hall. Suppose some of the particular human beings, we are having blood sugar abnormally high, suppose. And some of the particular persons are there who are having normal or something below than that particular normal. So we have two different classes available. And these are diagnosed, suppose. These are already diagnosed that some of the particular individuals are having abnormally high this blood sugar level, and some of them are having the normal level or below that one. So already two classes are there, and that is being identified. The person one is having this problem, person two is not having the problem, etc. So two classes are there. That means the levels are given. These are having the problems. These are not having the problems. Class 1 and class 2. So suppose I am coming here as a fresher. So with certain qualities and the corresponding characteristics. So thing is that whenever we are going for the diagnosis, when doctors are there, you know it better that with the help of certain diagnosis, say different trials, different tests, etc. Suppose there are 3 tests. I'm not an expert, but let me tell you that there are 3 tests to idealize that whether the particular patient or individual is having this particular problem or not. And with the values of these 3 tests, you have seen the values are given for these 3 different trials, trial 1, trial 2, and trial 3. And these charts are available for all these persons present in the hall. And we have the diagnosis report that yes, we have it, problem is there, or no, the problem is not here for this person. So we have a complete chart. Now I'm the person coming and sir is asking me, please provide me the test reports. So I'm readily giving it to accept it. This is my test 1 report, this is my test 2 report, and this is the test 3 report. Suppose at this moment while receiving that one, he went to have some other urgent call meeting. And some junior is there who is not so experienced to understand whether with these 3 test reports, what is the conclusion? Whether I should call that this particular person, Kaushik Ghosh, is having this diabetes problem or not. So what he or she can do? With the help of machine learning, with the available data, suppose, he or she try to get the answer. Idealize if this is the chart for these 3 test reports, and if this is the diagnosis report, yes, he is having the problem or she is not having the problem, please provide me the answer. If these are the test reports for Kaushik, what should be the answer for these? Whether he will be having the problem or not having the problem. So you can see here the classification problem. This is called classification because already some groups are there and these groups are leveled. That is the problem. We have to assign some new person or some new pattern or new object, whether he will or she will go to this particular level or to that other level. This is called classification. What is then clustering? Clustering is something like that while levels are not provided. Suppose I just see here the sitting arrangement. If I try to understand the corresponding idea how you are sitting, you can easily understand this issue that some of you are clustered at the very last end. Some of you are here at the middle end and a minimum persons are available at the front seats. So someone is asking me, make some groups with the persons being distributed in that particular pattern. So I suppose that optimally I can understand there would be 4 or 3 different groups. That is quite actually sufficient to make everyone available in these groups. So this is the process where there is some kind of independence. That means the levels are not provided. You have to identify how many groups you have to create. And accordingly, that should be an exhaustive process. That means everyone should be in some of the groups. And second point is no particular individual should be 2 of the groups. Because this is going to be mutually exhaustive process. Everyone should be there in some of the group. No particular person is unassigned. And second is there is no overlap. That means if some person is in the group 1, he or she will not be in group 2 also. That is the most fundamental point. This is called clustering. So when I am talking of the process, this is going to have the second kind of objective, which is supposed to be either classification or clustering. And on the basis of that one, while I'm talking of the machine learning, there can be 3 categories. And Professor Naman Goyal has mentioned that one. I'm coming to detail of that one. The very first one is called supervised learning. As I mentioned, that when the classes are given, some levels are provided, we have to make this particular process. This is called supervised learning. Second is called unsupervised learning technique, which is where we are having some independence. We have certain people, some individuals, some different characters, some patterns are available. We have to group them properly with certain characteristics in a disciplined manner. That is supposed to be unsupervised learning. And third one, this is called reinforcement learning. This is something new. Before going to that particular detail of that one, let me come to the point that, is it stored here? Yeah. So before going to the detail to that one, let me, not working. No. Please just wait. Yeah, thanks. Okay. Yes, that is my point of concern. You just look at the figure properly. So what is actually the story behind the figure? There are 3 different patterns of 3 different figures I have taken. At the leftmost corner, you have seen that mother is actually trying to make her child to learn how to write A. So there are 2 different parts of this story. The very first one, let me tell you that here the process is quite guided. That means, while we are learning at our infancy, while we learn how to write the things, you have seen, this is all our custom and all our experience, that my mother or my father or any other parental figure, any senior present in the house, he or she will make me learn in that way. Just hold the finger properly, put your pencil tip or the pen tip properly in this manner. What should be the angle? What should be the pressure? What should be the posture? Everything is being guided by mother or by my father or anyone. This is called supervised learning. That means we are having a process of learning where every step is dictated by a discipline mathematics. This is called supervised learning. Look at the second one. This is unsupervised learning. Why so? Because this is actually the main problem. This is the difference. What is the categorical difference in the second one? This is also kind of learning. Thank you. So this is a kind of learning also where we can see that a child is trying to learn how to walk or how to run. So try to understand, focus on these issues, how we write, how we started to write, and how we have started to walk or run. That is a different perspective. Why it's different? Because no one was there. That is humanly impossible that my father or mother is holding my legs and hands are particular, any backbone or whatever it might be, supporting us. Just to put your leg here in this way, put your leg in that way, that is not possible. So how we learn? We learn from the imitations. That means we try to see how my father, how my mother, any other grandparents, they are moving, they are walking, they are running, whatever. And we try to learn in our own way. But there are certain problems. That is called actually the classical thinking of unsupervised learning. Because how we have learned, we know our particular parents, they are having different body shape. They are quite old enough. That means they are having different body posture, their body weight, their height, that's quite different. And for that reason, how they have actually moved, the classical thing is not working for me at that time. And that is why we failed in different cases. But finally we learned. So that means this is a kind of process. We have some indirect measurement of learning. There is some mathematics provided. We have to be guided by that mathematics, but not strictly. We have to incorporate that mathematics in our own way so that we can make something new. This is the process of unsupervised learning. And you can see the third one at the very right corner. This is called reinforcement learning. What is that one? It is actually a classical example of reward and punishment. See here, that is, a child is there. who is actually being motivated by his father, providing pizza. Perhaps the child has done something good, might be a good score in the exam paper, might be something else. Father is very happy, and that is why he is providing the pizza. This is reward. Think in a converse way, the directed way. That means suppose some particular thing is not done properly by his child. What he would do? He will scold that particular child so that he cannot just repeat the same thing in the next day. So it is actually a form of punishment. So while we are talking of reward and punishment in the learning procedure, that is a different perspective. For example, a robot is there, and robot is trying to learn from his master. So what can be the procedure? Well, a robot is being instructed and it is trying to just follow the guideline properly without any mistake. Master can provide a toffee to the robot. That is not possible. Or suppose robot is making a mistake. So master is there who is actually not just being happy. So he or she is very distressed and scolding the robot. That might not be a good issue because robot being not human, it will not understand what is the actual utilization of the toffee and what is the process of scolding it. That is not to be understood. So what we can do alternatively, we can provide a positive feedback, electronic mechanism positively to that particular robot if it works properly. That is, the motion is being accelerated. This is one favorite thing what we can do. In the opposite direction, if it is not making the things properly, making a mistake, we can provide a negative feedback, negative pulse to that particular robot so that it can feel that my movement is being somehow restricted. That means if I just follow the same argument in the next step, I will be again having this blockage. So let us not to do in that way. This is actually a kind of indirect learning, which is actually called reinforcement learning. So you can see here, if I just go back to the slides. Yes. So can we just off this one so that, yeah. See this example, this is your classical domain example, what we have here. This the thing is one example of reinforcement learning in the domain of homeopathy. Might be very, very basic one, but still you can understand. Suppose a doctor is trying to make some remedy to a particular patient sequentially. So look at the step one, what he or she is doing. Aconite is given and improvement score, if I can just swallow that improvement score after just having this aconite to the particular patient, it is having the improvement score as 2. While belladonna is given to that particular patient in the step number 2, sequentially, you can see the improvement score is 3. And while arsenicum is given to that particular patient, we can see in the third step, the improvement score is 8. So looking at the chart of the improvement, what we can say, there are 3 different things. What is there in the process of reinforcement learning? One is called here, the state, the second one is called the action, and third one is the reward. So state is here the patient condition. Action is the remedy or potency, what is being injected, what is being given from the doctor, and reward is the improvement. So if I see that improvement score is higher, reward is higher, we will follow this argument, this remedy or this potency properly. So optimal policy is choosing the remedy with higher expected reward. That is here in this case would be arsenicum. This is one simple example what I try to provide in the domain of this homeopathy where we are trying to apply this particular process of what is called the reinforcement learning. So I think that idea about the supervised learning and unsupervised learning and the concept of reinforcement learning, perhaps it's clear to everyone so that we can move on to the next slide. So if I'm just yes. So let me continue here. Yes, there might be some technical glitch, so I will be following that one. So anyway, the problem is what we have here in the present discussion. I will be trying to provide some of the mechanisms with a very nutshell because I cannot have all the descriptions. I will focus on some of the particular experimental problems and try to understand the scores and try to understand the application answers. Of course, I have focused on some problems of the homeopathic treatments so that everyone can follow my argument and principles properly. Okay. So yeah, I'm coming to that one. Just wait for some glitches there, perhaps. Slideshow. No. Come to the slideshow, please. Slideshow. No. Yeah. Is it moving? Yeah. So the point is, at the very first level, I will try to provide the idea of the regression analysis. Because as I mentioned that there are two different objectives while we are learning the machine learning. One is about the corresponding idea of the estimation or forecasting, and second one is the classification or class study. So I begin with the study in the process of regression. So while we are learning regression in a very brief manner, let me tell you that there are different categories of learning the particular process of regression. First thing is that which is called the simple regression while we are having only two variables. Suppose I am talking of the prices in Delhi and Kolkata. There are only two variables, X is Delhi's price, suppose, and Y is Kolkata's price. Of course, this particular example I am providing from the non-healthcare dependent particular problem, but I do have some other examples also. But let me just have this simple example while we are having two variables only. This is called simple regression. But if I have at least three variables, suppose we are thinking of the prices of at least three metro cities, say Kolkata, Delhi, and Mumbai, or having four different cities or more than that. So at least three variables or more than that. That is corresponding to the idea of the multiple regression. So it depends on the particular procedure about the requirement what we have. We have to select first the methodology, whether we have to focus on the simple regression procedure or the multiple regression procedure. Some other cases, we have to also focus on the structure. That means finally, what is my objective? Is it to provide, suppose, let me think of the idea of Delhi and Kolkata's price. Is it just the feeling of that we will have a straight line? That means if I suppose Delhi's price is X and Kolkata's price is Y, we are actually looking for whether a straight line, that is Y is equal to some A plus BX, or any quadratic version of that one, that is, for example, Y is equal to A plus BX plus CX squared, or something else. On the basis of that particular choice, we have to understand whether we are looking for a particular procedure of a linear regression procedure or a non-linear regression. Linear regression means if I have two variables or three variables, even more than that, all the particular variables will be present with degree 1. That means if I have X, if I have Y, if I have Z, there should not be any particular position of X square or Y square or Z square or something else. Everything will be present with degree 1. That means X means X, Y means Y. That should be not be Y root 2 Y or square of Y, anything else. That is not allowed in this case. But if I just don't have that one, any particular change is there at any position, minimum change. If somewhere Y is Y square, if somewhere Z is Z cube, at least one change is there, which is not with degree 1, then entire system becomes non-linear. So we have to understand what kind of structure we are looking for. Accordingly, we have to choose. Last point is about, which is supposed to be the partial regression and total regression. You can understand it very easily. For example, suppose we have a composition of some medicine, and where we have certain ingredients. And you have seen that with these ingredients, this is my output or the performance level. Someone is advising you that you may just have incorporation or a mixture of some 2 or 3 more variables, 2 or 3 more different medicines, some different chemical components, so that the idea is now that score might be actually enhanced. This is one kind of feeling. That means you are supposing that way. It might happen. So how should I do? We have the ideas that how this particular different chemical compositions are working together. We did have the idea that this is the knowledge. If I have 3 variables, X and Y and Z, these are the chemical components available. How X and Y, they relate to each other. How Y and Z, they relate to each other. How X and Z, they relate to each other. I do have the particular ideas. But we are now incorporating some other 2 variables, say A and B. So I have to look upon this corresponding concept that how this new foreign element, C and B, will actually work with X and Y and Z. This is called partial regression. And what is about the total regression? Total regression is supposed to be, for example, we have a particular medicine where we have different chemical compositions together. And I just have a feeling how this particular dynamics, chemical kinetics is working together. That means, for example, suppose we have a case of n number of different, suppose 10 different chemical compositions are working together to create a medicine, for example. So we have to think pairwise. Suppose we have the first composition, second composition, third composition, etc. So how many pairs possible? Perhaps everyone can understand. This is higher secondary or secondary level learning. 10C2, that is 10 into 9 by 2. Perhaps 45 different combination pairs will be possible. So my idea is we will learn how these different 45 different pairs are working together. That means one is acting with 2, one is acting with 3, 2 is acting with 4, 5 is acting with 7, this way. So 45 different combinations of pairs are possible. And for each of the pairs, we are trying to identify the knowledge. And perhaps with this 45 different combinations of pairs, we can produce the entire Thala knowledge. This is called the total regression. So this way, we can just move on to the concept. This is supposed to be here. Yeah. So I'm not going to example. This is quite easy. So let us come to the corresponding mathematical concept, how it works. For example, suppose we are looking for this y is equal to a plus bx. That is a case of very simple case of two variables where I suppose that y is my dependent variable and x is my independent variable. For example, let us suppose a case that I am providing a chart of Kolkata and Delhi. Delhi and Kolkata. Delhi is supposed to be the variable x and Kolkata is y. On the basis of that one, I just provide the final question that if this is the price of Delhi, what should be the price in Kolkata? So I'm giving the x, try to get the answer of y. This is called the problem of y on x, where y is to be estimated on the basis of the choice of x. This is the first part. And you have the second part of the question where I ask you the reverse of that one. I provide you the question that given the price of Kolkata, get the answer of Delhi. That means I am providing you the y and get the corresponding estimation of x. Here it is called x on y type of problem where x is to be estimated at the left hand side with the help of the given y. This is called x on y type of problem. Here this is called y on x of type of problem. So this is my data provided. That means x1, y1 is the first data, x2, y2 is the second one with the size of capital A. How to get the equations? So you have seen that there are two different parameters present, A and B in the first case, and here we have two parameters present, C and D in the second case. I'm not going to the deep mathematics. It's a very simple level of mathematics what we will actually use here. The question is to be said that there are two different equations are coming out with the help of this normal equation procedure, that is the least square method. I'm not going to detail that mathematics here, just to have the final expression of that one. These are the equations. This is at the left hand side summation of all y. This is equal to n into a plus b into sigma of x. These are the chart provided. y1, x1, x2, y2, everything will be provided. This is the second equation. Sigma of these x into y, and this is going to be a into sigma x plus b into sigma x squared. Of course, please don't get afraid because I will show a simple example how the tables are to be formed and how to get the answer for it. So I'll just continue. This is the second part, that if I have a question of x on y type of problem, this would be the corresponding equations where with the help of this, we can get the answers for C and D accordingly. So these are the two questions what we have, two equations what we have to solve for C and D. It's a very simple thing of the mathematics. Now let us come to the point how to be justify that one, how to validate that one with this example. Let us take this simple example. We are providing a case of 5 different values of x and corresponding values of y. So this is x. If 3, then y is 6. If x is 2, then y is 1. If x is 7, then y is 8, and so on. 2 questions are asked. First question says, if I know what is x is equal to 11, you have to estimate y. So this is a question. X is given. Estimate y. That means it is an y on x type of problem. And in the second level, you can see y is given as 10 and you have to get the answer for x. So it is x on y type of problem. Let's see how it's to be done. Very simple. We will make this chart. This is the first column where we have all these x. Don't shuffle these. And y is the corresponding values here in the second column. We make the values of x square. 3 makes it 9, 2 makes it 4. Simple mathematics. This is y square column where 6 is 36, 1 is 1, etc. And this is x into y, row-wise multiplication, like 3 into 6 is 18, 2 into 1 is 2, like this. But we are not having any interest on any of the individual box value. We are looking for the corresponding column summation everywhere. Because these are the equations, what you can see. Mainly, these are the equations, what we are looking for, and everywhere we have the column sum. Like for example, sigma y, which is this one, T, I will use it. N into A, N is the size of the data. And B into sigma x, where it is 25 into B. This way, these are coming. For example, sigma xy, it is 178. I just put it. And accordingly, solving these two, I can have the values for A and B. Very simple. So getting the value for A and B, you can easily understand what will be the equation. That means y is equal to this one, A plus B into x. So if someone gives me any value of x here, I can easily find out the corresponding value of this y. So like something like this. On the basis of the second one, look at the chart once again. You can identify this is the corresponding equation where we have for the x and y. I put it from again the column table, and these are the corresponding equations. And I can easily get what is C, this is for x on y, and D, what is for coming this way. So these are the equations. This is the first equation, what we have for y on x. This is the second equation, what we have for x on y. Question is asked, if x is 11, find y. I put it here. If I put x equal to 11, I can easily get what is y. And second question is, if y is 10, what is x? I will put it here. X is here, y is equal to 10, and I can easily understand what will be the value of x. So this way we can estimate the corresponding things accordingly. Look at the question properly, whether it is a problem of y on x or x on y. And this is actually the lines what we have. You can see these are the corresponding dots, orange dots. These are the actual points. And this is the straight line what we have created accordingly. You may ask me a simple question. This is a big error, of course, because what the points actually we have, the straight line what I have generated, there's a big error. And that's true. Because just to show the example, I have taken only 5 points. But if I have a big data, suppose there are 100 or 200 or maybe thousands of points, if I use a proper mathematical algorithm and make the computer programming or Excel, whatever you want to do, you can make the chart and you will see that the particular level of these errors will be minimized somehow. So that is very true story, because number of data, if it is increased, we can easily make the corresponding thing of error minimized. This is the reverse cut. That means it is the x on y type of straight line, where again we have the points, and this is the corresponding straight line of x on y type. Only the reverse idea, that is the conceptual. If I have the x on y type, horizontal axis is y and vertical axis is x. But if I have this y on x type, actually what we made, this is your x-axis and this is your y-axis. So concept is different. That's why same point, how it looks here, same points is being changed accordingly, because x is now read as y and y is now read as x. That's the point. So this is one more thing I like to actually incorporate in basic words. In the practical examples, we have to rely upon the case of multiple regression procedure. And while we are having the multiple regression procedure, please remember that means we are having at least 3 variables or maybe 4 variables or maybe more than that. So let us just incorporate the idea that this is a case of only 3 variables. You can see I have taken x1 is my first variable, x2 is my second variable, and y is the third variable. The notation says, that is enough to understand, x1 and x2, these are the independent variables, and y is the dependent variable. That means y we have to estimate finally looking at the chart, and x1, x2 that will be provided. And how we make it? This is actually a simplified structure what we create. We use y is equal to a0 plus a1 x1 plus a2 x2. We have to idealize what would be the value of a0, a1, and a2 from the chart. And we can see that this is the process of getting the equations. Very simple way to understand this concept, just to remember. If this is my equation, make a sum. Sigma y, a0 is repeated for n number of times, that's why n is 0. a1 into sigma x1, a2 into sigma x2. That is my first equation. Now to have my second equation, I will multiply both the sides by x1. So x1y, a0 x1 plus a1 x1 squared plus a2 x1 x2. Make the sum now. Look, please, that is sigma of x1y. It is a0 sigma of x1 plus a1 sigma x1 squared plus a2 sigma x1 x2. To have my third equation, I will multiply both the sides by x2. So it is x2y, it is a0 x2, this is a1 x1 x2 plus a2 x2 squared, and have the sum. It's very simple to understand. So after having these 3 equations, my concept is I will make the chart to have the corresponding sum values, and I will generate the values for a0, a1, and a2 and get the solution. If we have a case of 3 variables plus 1, that means 4 variables where these x1, x2, x3, these are independent variables. And y is the dependent variable. Our corresponding structure may be like y is equal to a0 plus a1 x1 plus a2 x2 plus a3 x3. So your equation would look like this. Discipline is very simple, as I have stated. What is your equation you have assumed? Make a summation. Sigma y, a0 is repeated in a0, a1 sigma x1, a2 sigma x2, and a3 sigma x3. Very simple. To have the second equation produced like this, please multiply both the sides by x1. So it is x1y, it is a0 x1, a1 x1 squared, a2 x1 x2, a3 x1 x3. Make the sum. To have my third equation, multiply both the sides by x2 and make the sum. To have my last equation, multiply both the sides by x3 variable and have the sum. Very simple to understand. So there, in this manner, we are having 4 equations, and my corresponding job would be to identify the values of these a0, a1, a2, and a3. With this 4 equation, get the job done. Let me have a very simple example, then I will provide one particular example. Please try to understand this issue of the problem. And at here, if you have any time, try to get the solution so that you can feel the confidence that using this concept of machine learning, we can make the corresponding answer very simple. Let's see. This is your equation where we have a case like 3 variables, x1 and x2, these are independent variables, and y is the dependent variable. So you can see these are the chart provided. For example, 3 and 8, these are the values for x1 and x2. This is for y, like this. So what we will do? We will create a table like this. This is for x1. This is for x2. This is for y. These are the needed for x1 square, x2 square, x1 into x2, x1 into y, and x2 into y. As per the prescription, because we are having different cases where we are having different things to be done. That's why, as per the necessity of the equation, we have to create these tabs. And please remember once again, we are not bothered about any individual value in the table. We will be looking for the column sum everywhere. For example, this is sigma x1, this is sigma x2, etc., etc. After having all the values done with the help of any computer programming or very simple Excel sheet, you just generate the corresponding columns and the corresponding sums. You now have the equations. As I mentioned, this is the equation set, and put the corresponding values there accordingly. N is the size of the data, which is 5 here, and we have x1 sum, x2 sum, everything is available in the chart. And getting the solution done, we are having a0 as this. Can anyone please confirm who is actually online? Has it been shared? Screen has stopped now. Is it coming now? Has it come? So, thank you. And my voice is also coming there in the device. Thank you. So what I was telling you that this is actually the point of concern, that this is actually one example which is exercised and displayed. Let me come to this point. This is one simple measurement in your domain perhaps, might be a very basic one, but let us try to get this idea that it is a simple data set what is being given in different scales 1 to 10. So you can see that there are some patients. I have taken the case of say 20 different patients, and we are having the first variable as the severity. And you can see some different values are there. For example, in the case of the first patient, the severity is given to be 6 in the scale between 0 to 10, 1 to 10 rather. And in the case of sensitivity of that particular patient, which is supposed to be the variable x2, you can see the corresponding sensitivity, like in the first case, it's 6, for the second one, it's 10, and everything is taken again in the scale of 1 to 10. And this is actually the required diagnosed potency to be given to that particular patient. And you can see these are the values of the potency, what is to be done as y. So you have already a chart. So looking at this particular problem, suppose we have to create some expert device where I don't need at this moment any doctor. At this moment, suppose I just want to have the chart that looking at this particular case, if I provide you, thanks. If I provide you this particular case of, this is one new patient with this particular severity. Suppose I provide you the 21st patient, which suppose the severity as say 7, and the corresponding case of the sensitivity, which is given to be 4, 7 and 4. We have to identify what should be the potency to be prescribed to that particular patient. So without having any particular doctor, we just want to get the idea how it is to be done. So this is the simple way. This is your x1, this is x2, and this is y. The chart is given in the previous example, what we have scored. This way we will produce that I will make the potency as y. This is equal to a0 plus a1 into x1. X1 means severity plus a2 into x2, which is sensitivity. And looking at the similar things, what we have done already, like in the previous examples, what the procedure we have used. Similar procedure I will be using here also to identify the case, how to get the value of this a0, how to get the value of a1, and how to get the value of a2. So here in this particular problem, we have scored the values for a0 as this, a1 as this, and this is your a2, which is coming out to be negative. So what we will do, if I ask you the question in a case, fresh case, that we are having the severity as 7 and sensitivity as 4, I will put here x1 is equal to here as 7 and x2 is equal to 4. And putting the values, for example, 3.31 plus 3.15 into 7 minus 1.52 into 4, that will provide you the value of the potency, what is coming to be 19.28. That would be the prescribed chart. So this way, very simply, with the help of this machine learning technique, the regression old classical technique, I can identify the problem and I can just have the judgment that what can be the value of this particular potency if these things are provided. I think everyone can understand what can be the basic issue and what can be the possible application domain of this machine learning technique in this particular situation. Anyways, just to continue, this is one advancement, but I will not go to the detail of that one. This is called the lasso technique, which is now used, and I don't have to get the theory entirely, because while you would be using any particular package, might be MATLAB, might be anything in the particular package what is available, or in AI tools also. If you ask the AI that get the answer using the lasso, that will provide you the answer, which is some advancement in the old classical regression technique, where we have to identify one multiplier also, use that multiplier with this one also, and that multiplier is understood. You don't need to bother about that. Will make it the process here, and you can have the answer for it. So this is one technique just for the awareness. I'm telling you that perhaps if you don't want to use the regression technique, because you know the regression technique was developed in the year 1805 and 1809, more than 200 years back, by two famous mathematicians. One is Legendre, French mathematician, Legendre actually the spelling, and one is Charles Frederick Gauss. The years 1805 and 1809. And after that, Sir Francis Galton, who was an optometrician from British community, he actually applied this mathematics in the year 1870 to 1880s. Perhaps he published this report in the 1886, and he perhaps used the particular It's a very classical approach of supervised learning, where we have certain levels provided already. But clustering means something else. For example, suppose these are the group of people available in this particular hall, and I want to make a grouping according to your seating distribution. So this is a particular example of what is called clustering here. So I will be using one particular method. I will show you one very simple example of this K-means clustering and how this works. Let's see. Let us try to identify. Any problem? I think this has come. Anyway, so I just continue. So this is actually the method. Please make it full screen. Is not shared? Is it not shared? Shared already. So please leave it. Shared already. Leave it. No. Oh. If there is any problem, please tell me, then I can just help. Anyway, so the point is, let us try to identify this issue that what we will do here. First of all, I have to identify the how many particular clusters I want to make. For example, in a particular problem, I need two groups. That means K is 2. For a particular example, I need 3 groups. That means K is equal to 3. After having the number of clusters identified, the groups identified, I will just make this way that I will just consider one very simple case of centroid or center of any one of the groups. So I believe that everyone understands what is actually a centroid is. This particular, so this particular thing is, for example, suppose we have a point, say given as, say x1, x2, etc. We have one more point, which is given as y1, y2, etc. We have one more point, z1, z2, etc. So there are certain points with certain dimensions. How to get the cluster or center about that one? Center should be identified as very simple, x1 plus y1 plus z1, etc. by 3. Then if I consider 3 points, if I have more than that, of course, that number should be given. That is the count. How many points I have taken. Then I have x2 plus y2 plus z3 divided by the count. This way, the particular coordinates are selected. That means the similar coordinates are summed up, and we just follow the corresponding idea, what is called actually the mean of or average of this one. So on the basis of that choice, we can have the centroid. So what I will do, I will just finalize that this is my choice of center for the first, this is my choice of the center for the second group, etc. For example, let us believe that in this case, we have 3 different groups. And here in the very first group, I select him as the centroid. In the very second group, I select that person, that guy, as my second centroid. In the third group, I select that person who is standing there as the third centroid. And I finalize that this would be like 3 different groups, and these are the selected centroids. After that, what I will do? I will just make the assumption, let us choose any one of the particular point one by one. And I will try to follow what are the distances coming out from these persons from these particular centroids. For example, if I just have one person, suppose I select her, and I just want to find out whether she will be in the first group or in the second group or in the third group. So what should I do? So I will make a distance. You know the distance, how it is being counted. Euclidean distance, very simple. x1 minus x2 whole square plus y1 minus y2 whole square and the square root. So on the basis of that one, I will finalize what is the distance between her and him. What is the distance between her and him, the second group? And what is the distance between her and the third center? And then I will finalize among the 3 different centers what I have actually selected, which one is nearest to her. And I will assign her to that group. So that is coming, that is being practiced for every particular different points what I have chosen. So accordingly, we have a new shufflement that in this choice, everyone is selected, everyone should be clustered in any one of the groups. After that, after having this new reshuffling of the different points what are available, I will finalize in the very first group what should be the center according to the formula, what should be the center for the second group, what should be the center for the third group, and so on. And then I will again make the process. Everyone is now selected one by one. And then I will make the direction distance between every point from that particular center. And I will classify that particular person or that point to that particular group or cluster, which is nearest to that one. So accordingly, we will make the reshufflement and I will finalize when I have finished that one, that things are now stable. That is the final step of what we can produce. And on the basis of that one, we can just have one simple example. I'm not going to detail that simple example. I'm not going to that one. Suppose these are the points what I have selected. Suppose 15 points are there with these coordinates. The coordinate might not be always right to understand this is geometry. For example, 2 can be the severity of the disease, 10 can be the sensitivity of that particular patient. Like this, we have charted these issues. And accordingly, I will group the different persons accordingly, the different clusters. And I suppose that I will be using here, for example, I will be using here, say, 3 different groups. Say, this is my first group, this is my second group, and this is my third group. And I choose, this is my random choice at the very first level. I choose this particular points, 2, 6, for example. I choose A2 as my first center. I choose here 5, 10 as my second center. And I choose 6, 11 as my third center. And what I'm doing, I'm making the practice very simple, that I am finding out the distance of every individual point from 3 different centers. You can see that. And I will make the thing clear that which is the actual minimum one. Suppose, for example, very first point, the minimum distance is available for the centroid 2. That means it is now classified into cluster 2. That means second group. Similarly, for example, I can have one more example. Suppose this one I have selected. Point number 8 is having the distances like this. You can see this is minimum. So point 8 is also actually clustered in number 2, second group. So this is the new reshufflement what we have. And on the basis of now, we are having some of the points in the first group, some of the points in the next group, some of the points in the third group, and so on. And then I will make the things clear using the concept of the centroid. I will find out what should be the centroid of the very first group. That is here done. You can see this is actually the first centroid. This is actually the second centroid. This is the first centroid, second centroid, and third centroid. The next score is very similar procedure once again. I will again using the points and the new centers are there. I will find out one by one what are the distances. And see, for example, this is the minimum for the first case, so it is in cluster 2. This is minimum here for the third point, so it is in cluster 3 like this. So I will just continue the process till we have the stability in the entire procedure. This is actually called the K-means clustering procedure. So this is one application I try to show you. And this is being done. Finally, you have the steps like this, and this way you have done this particular thing. See, this is one example. We have in the domain of homeopathy, suppose this is a particular group, fever density is given this between 1 to 10 scale, and thirst level is given between 1 to 10 scores. And we have taken only 4 points, 4 different patients. One is having 2 and 3, these are the values. 2 is having 3 and 4. Third one is having 8 and 9. Fourth one is having 9 and 8. I choose there are only 2 groups, for example, K is equal to 2. And accordingly, we can see I choose here the 2, 3 as a first centroid. I choose, this is my random choice. And 8, 9 is the second centroid. This is your choice at the very first level. And what I will do, I will then find out every point, 2, 3 is how much distance from the first center. And 2, 3 will have how far distance between the 8, 9 points. And accordingly, we have the chance. And then we will try to classify that which point is coming to this particular cluster or not. And then I will move to the second one. This is, you can see the new particular cluster centers are done. And you can see this is the final chart because there comes the stability. You just have the practice in the paper, pen and paper. You will just use that one. You will see that after the next step, you will see the same results are coming. That means things are done. So in cluster 1, we have the first 2 patients. And in cluster 2, we have the last 2 patients. And this is being classified this way. So this is one simple example of the clustering technique with the help of these particular pattern values provided, the characteristics provided. We can easily chart them or classify or group them accordingly. This is one example, and I can increase that number. I may have x3, x4, and same things will be done here very simple way because that dimension may be increased, but the formula remains similar as this one. So one more thing I will tell you, this is a case of which is called classification. That means things are leveled. We have some leveled classes, and I will classify any new pattern into any one of the class. And how this is done? This is called the KNN. K nearest neighbor. And what is actually a common procedure of the K nearest neighbor? This is a supervised learning technique because here we are using the particular procedure of the classified levels are given. So let's see what one example. Suppose we are having these patients, John, Rachel, Anna, Tom, and Nelly. And you can see these are the 3 symptoms having for the John. John is having symptom 1 as 35, symptom 2 as 35, symptom 3 as 3. Russell is having 20 to 52, Anna is having this value, Tom is this, and Nelly is this. And you know, there is new patient coming. Say, for example, in one fine morning, David is available in the doctor's chamber, but doctor is absent. And his or her junior is present. And junior has to identify if these are the values, 37, 50, and 2, how David should be classified. There are two different classes I have detected with one particular disease, suppose malignancy or benignness. John is malignant, Russell is benign, Anna is malignant, Tom is malignant, and Nelly is benign. So David is to be identified with this particular scores or values for these three different symptoms, whether he will be in the malignant class or in the benign class. So what we are doing? First of all, we identify what should be my K. That means how many neighbors I will allow. This particular problem, I allow here K is equal to 3. That means 3 neighbors are taken. And how it is being done? Very simple. You can see here. I will find out, this is my test. So I will find out the distance of David from each of the points. Between David and John, you can see Euclidean distance. 35 minus 37 square, 35 minus 50 square, 3 minus 2 square under square root. That creates this result. Russell and David distance created. Hannah and David distance, this is created. Tom and David distance, this is created here. This is Nelly and David the distance, this is also created here. And now you can see among these 5 different distances what I have sorted out. As I have selected K is equal to 3, that means I will allow only 3 nearest neighbors to this particular patient David. And you can see the nearest distances are coming to be 15, the very first nearest one, 15.16 is the second one, and 15.74 is the third one. So I will allow Nelly, John, and Rachel only. And after that, the voting mechanism comes. Among these 3 choices, the mostly near neighbors, we are having malignancy here, benignness here, benignness here. So in this particular case, sorted out 3. Among these 3 neighbors, what we have highlighted, 2 is benign. 2 different patients are benign. 1 is malignant. So voting says benign wins with 2-1 margin. That's why David is selected to be benign. That's very simple like this. But the pertinent question comes here that what should be the basic choice of K? That means we have to identify a proper K for a particular problem. And that is one particular mechanism what we have for the choice of K once again. So, why do I have to keep problem? So anyway, so is it not moving here manually? I believe everyone online present, they can hear me properly. So I'm sorry, there is one glitch coming again, and we are trying to sort it out. Let's see. Hope shared. Takes time. I think it's now shared. Shared? Is it shared? Hope so. Can you see this? Yeah. So the point is, as I have stated this example, let me come to how to choose K. Very simple at this one. So please remember, there are 2 extreme cases I will not consider. I will not choose K to be very, very small. Because if I have a large data set, suppose 100, 200, 1000, I'm choosing K is equal to 2 or 3 or 4. That is not a good thing to do. Even I will not go with a very large K, because suppose I have a database, say 1000 or something like that, and I'm choosing this K as 700 or 800. That creates a problem because some unwanted things which are not necessary, that will come in the particular garbage and that will create some disturbance. So that is why we have to be very careful while choosing this K. And this is one thing we have that says that a very good score of K is near about square root of n. Square root of n means if I have size of the n, look at the size, how many data is provided, and take the square root of n. Say, for example, if it is 90, square root of 90 something is about 9 point something. So after having this value, which is of course 9 and some fraction level, I will identify the corresponding integer form. you know this is coming to be the greatest integer of this one. Square root of n, this is the greatest integer. That means suppose in 9 point something. So square root of n box function will just have the value as 9. But there is particular thing I have to tell. Because if I have a case of only two classes, like in the previous example, only two classes, benign and malignant. If I make this particular value of n, after choosing this particular thing, if I have this k, an even number, there is a last possibility in some cases while I'm going for the voting. Suppose we have k is equal to say 10. And I can see that after having k is equal to 10, I can see 5 of them are coming to be benign, 5 of them are coming to be malignant. So it's a tie. For that reason, what should we do? I will identify the value of the square root of n, make the box function of this. But please remember, if this is coming to be odd, it's okay. If it is coming to be even, make -1 to this and get the corresponding odd value. So this will work you in the particular process and that will help you in this regard. So this is actually the basic thing. You can see this is one example I have taken. This is please try means I will provide the slide. So anyone if interested, please try to make this practice, how it is working here. What happened? So how it is working here, you just identify that one. No, please come to this. It's okay. So you can see here, these are the 10 patients. And you can see that patient 1 is having the fever intensity 2, thirst level 3. And remedy was already scored, that is being recorded, belladonna is given to him or her. This is for the second case, 3 and 4 are the values. Belladonna is given for the third patient. For the next set, 4, 5, and 6, bryonia is given, arsenicum is given to this particular patients. Might be pulsatilla is present, may not be given. So these are the things being provided. Now the question is asked that taking k is equal to 3, that means I will have only 3 neighbors. I will identify if I have a new patient with fever intensity 7 and thirst level 4, whether he or she will be actually given as belladonna or bryonia or arsenicum or pulsatilla, like this. So how will I identify? Just a very simple argument. What I will do, I will take the point 7,4 for the new patient and I will make the corresponding distance between 7,4 and 2 and 3. 7,434, 7,442, 7,489. I will identify the distances here as the previous example being cited. And I will identify among these 10 different distances what is available, which are the 3 different distances nearest one, that is the smallest one. And after having the smallest 3 different results, I will have the corresponding remedy. What is the remedy being given? And then I will just having the voting mechanism. Out of the 3 different particular nominated neighbors, nearest neighbors, which are the corresponding prescription. And whoever the winning in the votes, I will go accordingly and I will provide belladonna or arsenicum or bryonia accordingly to that particular patient. This is the way to mechanize the particular issue. So I will now come to a very small aspect of perceptron. Basically, perceptron is the fundamental thing about the neuron. It is called the artificial neural network. And what is the meaning of the word perceptron? Perceptron actually comes from the 2 words. It is a hybridization of 2 English words, perception and neuron. So when the perception word comes, I am taking the particular segment, percept, and from the neuron, I am taking ron. So if I take percept and ron, this makes the word perceptron. So from this, the idea should be very, very clear. Please leave it. So idea should be very, very clear that perceptron makes the idea that we are using some machinery, a particular mechanism of machine learning. With the help of that one, we are trying to make some imitation how human thinks or how human actually just capitalize the matter or execute. Might be this is a challenging issue because how human thinks, human particular thought process goes on, we don't understand properly. As we don't understand, we cannot provide or supply that particular idea to the machine. So this is being done imitated in a different manner. We craft one simplified argument, how to get the patterns, how to identify the patterns, how to just have the output similar as a human works. But please don't think that this perceptron is actually thinking like a human brain, not like that. We are looking at the input, we are looking at the output. If these are the inputs, how a human being will make the output, we do have a long chart of that one. On the basis of that one, we create a very simplified algorithm for that one, so that if these are the inputs, how the output can be actually identified by a machine. This is the idea what we have for the case of perceptron. So in the case of perceptron, these are the main mechanisms what we have. These are the corresponding factors. One is the input, second one is the weight, third one is the net sum, and fourth one is the activation function. I'm coming to a very simple aspect of that one. You can see this is actually the input, where different features are given. For example, I will suppose here, this is the severity of the patient. This might be the corresponding thirstiness. This might be the corresponding sensitivity of the particular patient, etc., etc. And we will have the corresponding weight functions assumed here. Please remember W naught is supposed to be the bias. For example, while we have moved for the regression procedure, you have seen y is equal to a plus bx. A is one particular parameter which is not involved with the variable. This is called a bias. For example, if I have three variables, we have taken the regression as y is equal to a naught plus a1 x1 plus a2 x2. So a naught is supposed to be the bias. So in that procedure also, we will be having one term which is actually the bias, which is just multiplied to dummy one. So if you look at the sum, it would be W naught into 1, that is W naught plus W1 x1 plus W2 x2 up to Wn xn. After having the sum, we will just create one step function, activation function. And on the basis of that one, I will try to relate whether that particular results of these x will go to this particular class or to the other class or to some other class, etc. Like this. So we have the simple mechanism what we have here. You can see this is the sum what I have created. These are the W's I have to identify. These are the feature values already available. And X is the suppose I have the sum. And I identify a function. Just for an example, I identify one function which says if the sum is greater than 0, it will belong to first class. If the sum is less than equal to 0, this will go to the next class. If it is a 2-class problem, if it is a 3-class problem, I will have 3 different values of the function as this goes on. So this is actually the basic mechanism what we have. And today we use, instead of using the concept of artificial neural network, we call this deep learning. I will come to that one at the last level. What is deep learning? But let me have the examples here. This is one more example, just the previous example we have seen in the KNN. I will be articulating that one in the ANN also, artificial neural network. Same problem, that is not to discuss. We will try to understand whether David with these particular scores, whether he will be classified as malignant and benign using the concept of artificial neural network. Let's see. So we just have these particular things. For example, here we make the sum as W0 plus W1 x1 plus W2 x2 plus W3 x3. We consider x less than equal to 0 means malignant and sum greater than 0 as benign class. We identify that way. So what is happening here? As you have seen in this case, 35 is x1 for John, 35 x2 for John, and 3 is x3 for John. So I will put here in the sum 35, 35, 3. Let's see. You can see 35, 35, 3. I put here for this W x1, x2, x3, and I get this. As I know, John is malignant. That's why the score is taken. The x is taken to be less than equal to 0. Similarly, for each of the patients available, we have less than equal to or greater. Like for example, in the second particular example, I just say this one, Rochelle. It is benign. That's why the sum is taken to be x1 22, x2 50, and x3 2. I put it there. But the inequality is supposed to be greater than 0 here. You can see this is greater than 0. And everywhere we can see less than equal to 0 or greater than 0 accordingly. What will be my final intention? Using any algorithm, or even you can ask AI or ChatGPT or any other thing. You just provide you these inequalities and ask it, what can be the possible answers of these weight? And I have seen, you can see the varieties. There are plenty amount of answers, actually infinite answers. And I have selected 4 of them, 4 options. And for the David case, for David, we have the values 37 as x1, 50 as x2, and x3 as 2. I provide the particular case for each of the answers. If I select these W's, if I take these x1, x2, x3, I get these answers. So you can see in the very first 2 choices of W's, you are getting the score X as negative, which says it is to be malignant. But for the 3 and 4, these choices of W, it is going to be greater than 0. That says benign. So we are confused. And if you are asking the AI, that will provide any one of them. and it might be a very serious mistake in the medical case. So you have to be very careful. Why it's happening, I'm coming to that one, but please be very careful while using the ML or AI technique in the device and get the answer. Please don't make it a practice that this is my answer, so I'm done. No, may not be always. Let's see what is actually the main confusion. So this is one example. One more thing I have taken. This is a case of 4 patients having the fever intensity as 2767 and thirst level as 3956. And dosages are given, remedy is given as belladonna, bryonia for the 4 patients sequentially. So what I'm doing, let us suppose that here X summation less than equal to 0 suggests for belladonna and bryonia for greater than 0. So I do have the cases accordingly. You can see X1 is 2 and X2 is 3 for the first patient. So I put here W0 plus 2W1 plus 3W2 because the sum is W0 plus W1X1 plus W2X2. And why it is taken to be less than equal to 0? Because it's a belladonna. That's why less than equal to 0. For the second one, as it's bryonia, the sum is greater than 0. You can see 7 and 9. It comes here. So we have 4 inequalities, and we are searching for a solution of these possible W's so that all these 4 inequalities are satisfied. You can see these are the different 4 choices I have taken only because there are infinite solutions. But you can see if I take a new put, this is a new value with fever intensity 7 and thirst level 4. I want to identify what would be the answer. What is the remedy suggested? You can see with the first choice of solution 1, greater than 0 is a sum, so bryonia is selected. For the second, greater than 0, bryonia, but for the third and fourth, less than 0 is coming. That means your particular definition says you have belladonna in particular case. So what is the confusion? Again, we are having some confusion with this data. So let us try to identify, because using AI and ML, that's a good practice. But also we have to identify the limitation or the suggested remedies so that if this kind of problem appears, how we can make the solution out of it. That's the main important part of the job. So this is what we have here. This is your neural network, a multi-processing computational system with simple processing elements, high degree of interconnection. Scalar messages are simple, adaptive interaction between elements. I'm not going to detail. This is the particular technical attributes what we have, but these are the limitations. If the input vectors are not linearly separable, neural network doesn't work. Let's see. You can see here, these are some particular patients available here. These are some patients available here with the corresponding attribute values. And you can see you can make a particular straight line or a particular plane in between so that we can separate. But look at it. Here a mixture is provided in some manner. These are the some particular group of cases, some group of other patients. And can we create a corresponding straight line in between so that they are properly separated like this? A border cannot be created. So in this particular geometrical arrangement, if you can see this kind of thing coming for a particular group of patients with these corresponding attributes, please don't apply ANN because it will fail. You will get some fancy answer. If you put garbage to the computer, it will smartly provide, AI will smartly provide with a chuckle. This is your answer. But please don't believe that answer because that answer is heavily being biased with this particular situation. So please don't apply. This is one limitation what we have here. Second point, this is a nature of black box type. As I mentioned already, it is not understanding how human works. For example, if you just follow a stray dog or a stray cat, you have seen that a stray dog or stray cat can actually cross a road, traffic, without a traffic signal. It can cross the road with 99% accuracy. So if you try to identify the mathematics behind this one, how a particular cat or dog is moving, is it like that? Cat or dog is having a pen and particular paper. It is looking at this particular vehicle from the left-hand side, right-hand side, measuring what is the distance, measuring what is the speed, what is the width of the road, what is my maximum and minimum velocity, calculating some differential equations, getting the solution that it is moving. No, not like that. The thing is being crafted to the corresponding brain automatically, so this is spontaneously acting is come. The action is very spontaneous. The mathematics is already there in their brains. Forget about human beings. They are clever enough to understand these issues. But even being a human, we cannot identify what is the exact mathematics there inside their brains also. Forget about human brains. So that reason, please remember that artificial intelligence is not at all intelligence. Actually, it is artificial cleverness. So it is a kind of complicated crafting so that what are the inputs and how a human or mammal is actually working in that environment and what the output is being generated. We do have a long series of the values. These are the inputs. This will be the output. On the basis of that one, we create a simplified algorithm so that if some new elements of these inputs are provided, it will try to understand the output. And perhaps in most of the cases, we will successfully see how a human makes that output. The machine will make similar kind of output, but it is not like that. It is thinking in this human way or a particular cat's way or a dog's way. It's not possible. So that is my point of concern. So that's why it's a black box type of problem. And third is to have a good and reliable result, it requires much more data compared to other traditional algorithms. As in the previous cases, you can see we have taken only 4 data. Here also, we have taken some 5 data. That is why we have generated this kind of confusions. Because if I have more number of data, you will see there should be variations in the W's, but these W variation will be a very, very narrow scale. And that is why we will get some certainty answer in that particular procedure. But here it fails because the answers are quite wild. This is the choice of minus 83 for the first case, 13 in the second case, 300 in the third, 420 in the fourth. You can understand abnormally things are changing. That's why you shouldn't have a proper answer out of it. So be very careful about the choices. If you don't have a large set of database, if you see that things are not there like this, linearly separate is not coming, please don't use ANN in this case. That's my request. So this is one very articulation of these neural network for the inputs. These are some hidden particular layers in between we can graph, and this is the corresponding output. This is a case of which is called the shallow learning and deep learning. Shallow learning means in between we have less number of hidden layers. And in between, if we have more number of hidden layers, that becomes deep learning. So look at it. The child is trying to learn. Before the examination, if she revises more and more, perhaps she will understand the text properly. So number of layers, what is being actually injected in between, that creates the revision in the process. If you increase the number of revisions or the number of input layers or hidden layers, perhaps it will try to project the answer in a better manner, in a realistic manner. That is the point of answer. So lastly, I will be coming to a very interesting one, which is called the naive-Bayes algorithm. This takes from the probabilistic approach. This says this is coming from the very aspect of conditional probability. Please remember where is the difference. This is actually the new class of domain. In the previous examples you have seen, I have used the corresponding feature values with some quantified given numbers. But may not be always things are given in numbers. For example, here, I can have some attributes which are giving the precision high, low, moderate, high, cold, etc., etc. So if these particular adjectives are provided, these scales or categories are provided, I cannot use this particular methods what we have used for KNN or artificial neural network. So in those situations, we can apply the Bayes theorem, which is the conditional probability, all we have learned in school days, and I'm using that one. This says about this one, probability of A slash B. This is probability of B slash A into probability of A divided by probability of A intersection B, like this. So naive-Bayes independent. So the features what we are using, these are independent of each other. So let us have, without wasting the time, let us have this particular rhyme. In our childhood days, we have learned this rhyme. Rain, rain, go away, come again another day, little Johnny wants to play. So looking at the story, let us have this. So there is a chart. You can see, this is a chart of 14 days where we have seen the climatic outlook are like rainy. Some days are rainy, some days are overcast, some days are sunny. So there are 3 different attributes I have taken, either rainy or overcast or sunny. And things are provided. These are the results, what is being already known to us. Did Johnny play? In some of the days, Johnny played. In some of the days, Johnny didn't play. So no and yes, these are the categories answered. So accordingly, this is a question being said that looking at the problem, suppose, will Johnny play if a new day appears to be sunny? That is the first question. If a new day appears to be overcast, will Johnny play? If new day appears to be raining, will Johnny play? These are the questions being given in the particular problem. So how you will understand? So this is the chart what I create. Frequency table. You can see sunny, climatic outlook, overcast and rainy. These are the three outlooks we have already here. So we made the frequency. For example, how many rainy days are there? 1, 2, here 3, 4, 5, I think. So you can see the frequency. 5. Overcast 4. Sunny 5. Also categorize if sunny, if overcast, and if rainy. How many days are yes, how many days are no? For example, a total 5 days are sunny. And look at the sunny case. How many days were yes, how many days were no? Let's see. I just identified the sunny case and let us try to identify these ways. Sunny, yes, 1. Sunny, yes, 2. Sunny, no, 2, 1. Sunny, yes, 3, 1. Sunny, no, 3, 2. So like this, 3, 2. This way, overcast 4, 0, rainy 2, 3, etc. So these are the generations what we have. Now the question of probability, very simple. We don't require a new mathematics. The probability here. If I ask you the question, what is probability of yes? It should be 9 by 14 because out of 14 days, 9 days were yes. What is probability of no? 5 by 14 because out of 14 days, 5 days were yes. No, rather. Probability of sunny, that means out of 14 days, 5 days were sunny. Probability of overcast, out of 14 days, 4 were overcast like this. Probability of rainy is like 5 by 14. This comes the question conditional probability. Probability of sunny / yes. What does it mean? It means I know the day was yes. That means sunny played. Johnny played, brother. So what is the probability that sunny day was sunny? Look at it. Out of the 9 yes days, there were 3 sunny days. So it should be 3 by 9. Probability of sunny / no. Come to this no. 5. 2 days were sunny. So it's 2 by 5. Similarly, overcast / yes. 4 by 9, like this. 0 by 5 should be for his overcast / no, etc. This way we can have the answers. Now, what is the question said? Question is said, if a day was sunny, then whether Johnny played on that day or not. So what should I do? I will comparatively study the probability of yes / sunny and no / sunny. And I will identify which one is greater. If it is greater, then answer is yes. If this is greater, then the answer is no. And similar arguments for the other problems like yes / overcast and no / overcast. That means if the day is overcast, what is the treatment? Whether Johnny played or not. I will identify these probabilities, comparatively study and get the answer. So this is the way to treat. So you can see the problem. According to the Bayes theorem, if we apply probability of yes / sunny, it would be probability of sunny / yes into probability of yes divided by probability of sunny. This is actually the law. Probability of A / B into probability of A by probability of B. Simply like this. So if you look at the value, sunny / yes, 3 by 9, yes is 9 by 14, probability of sunny. Already we have made this 5 by 14. So it's 3 by 5 here. And probability of no / sunny is coming to be 2 by 5. Which one is greater? 3. So it is answer as 3. So due day sunny, that means Johnny will play. So it will be like this. Similarly, for overcast issues, we are getting probability of yes / overcast is 1 because other answer is 0. And that's why it is very sure the other answer is 0. So it will be like this. If it is overcast, Johnny will play. Probability of yes / rainy, according to that rule, it's coming to be 2 by 5 and no / rainy is coming to be 3 by 5. So it means this is greater. So no is my answer. So Johnny will not play if a new day appears to be rainy, like this. So I can enhance these attributes. And here I will be following the argument of the Bayes theorem like this. It's very simple, where instead of only one attribute, we make different number of attributes and these are multiplied. Every such case will be multiplied with the complete divided by the total. So I just have this example here. Here a case of, let's see, this is the chart. Only one case was provided in the previous. I now enhance one more issue, that is temperature. So this is one climatic outlook. This is the first, and this is the second attribute, temperature. And these are the things Johnny either played or not on those days. These are done accordingly by this manner. So I will be having the corresponding things. I will have frequency table for each of them. For climatic outlook, that means I will concentrate on only first column. And this one, I will get the corresponding frequency table for the first column. And like this, we will generate the answers. And similarly, for the second one, temperature, looking at these column and looking at the Johnny play, these two columns, I will generate the frequency level 2. That means please remember how many attributes are there. Individually, I will create these number of frequency levels and I will generate the answers accordingly for this. And similarly, these are the cases hot, mild, cool, where similar pattern. We make the yes and no. These classifications are done. And accordingly, we can create the corresponding answer looking at this chart and find out the corresponding absolute probabilities as well as the conditional probabilities. So, what is the question being suggested? If I come back to the question, you will see that the question was asked like this. Will Johnny play if a new day appears to be sunny and hot? So if this is my x1, if this is my x1 and this is to be x2, I put x1 is sunny and x2 is hot. Out of the three categories, I choose hot here and I choose sunny here. So accordingly, we should have, this is actually the question being set. This is actually to be understood that I will find out probability of yes on the basis of the hypothesis sunny intersection hot. That means intersection means here both are coming inclusively, simultaneously, sunny as well as hot. And also I will find out probability of no under the hypothesis sunny intersection hot. And then I will identify which one is greater and that will be my answer. On the basis of that one, this is my projected field. If I look for probability of yes slash sunny intersection hot, it would be probability of sunny slash yes into probability of hot slash yes divided by multiplied by probability of yes divided by probability of sunny into probability of hot. I put it together from the table and I got the answer as 7 by 15. On the other hand, if I look for probability of no slash sunny intersection hot, this comes the story, sunny slash no, hot slash no probability, etc. And this is making the thing 14 by 25. And out of the value 7 by 15 and 14 by 25, this is to be greater. So probability of no is coming greater than probability of yes. So my understanding is if a new day appears to be sunny and hot, Johnny will not play. So this is actually going by this manner. I can have a third problem where we have enhanced these three different categories and we can make the answer. This is a question I have set and try to get the answer. This is one problem of a case of medical data set where we have 10 different patients with these age groups. These are the blood pressure, which is the values are not divided, but it's given to be high, normal, and low. Three categories I have chosen. This is the second variable, cholesterol, where high, normal, etc. These two categories are chosen. And for smoker condition, if yes or no, these two categories are given. And whether he or she is having the disease, these are diagnosed as yes or no. So these are the two classes already provided. On the basis of that one, we have to understand. Suppose one patient is there having the age group 52 and blood pressure high, cholesterol high and smoker, yes. Whether the patient will have the particular disease, that means whether it will belong to the yes class or no class that we have to identify. So this is the thing I have done. I'm not going to just read out everything. So I identify how many of them are yes. I can identify 5 and no is 5. So yes probability and no probability comes to be 5 by 10, 5 by 10, each of them 0.5. And look for the conditional probability. That means disease. If yes, 4 out of 5 patients have high. So probability of high slash yes, it is 4 by 5. That means if I consider 5 patients which are having the disease, you can see 4 of them are having the high. Just check it out. Look at the yes, high, yes, high, yes, high, yes, normal, yes, high. 4 of them are high. That's the thing. So this way we can identify from the table different conditional probabilities and we can score them accordingly and we can generate these answers for different cases like high cholesterol slash yes, smoker, yes. And this is, if I say if it is a smoker, then if I know the patient is having that disease, whether he or she is a smoker, that can be identified from the chart. So everything from the identification can be made from the chart. So this is the final thing what we have to do, that I will look for probability of age greater than equal to 45 because it was given to be 52. I make this thing and look at these things also. So this is the question. Question is being asked that if this is the case, probability, yes, under the hypothesis age is 52, blood pressure is high, cholesterol is high, and smoker is yes. These are the conditions provided. I will find out the probability of yes. And this comes as on the basis of the value 0.1536 divided by the same ratio what we have. I'm not counted the ratio because that will come similar for the no case also. So it's better not to take. So probability of no on the same corresponding things, it is coming to be something like, yes, it is coming to be something, what is the value? It would be some 0.08, something like that, divided by k. So your answer is 0.15 and 0.08. This is greater. So that's why your patient will have yes answer. That means it is classified the new patient as disease is yes. That means he or she is having the disease. So, oh, sorry. Yeah. So one more problem, but I have not solved or perhaps I have meant the hint, because you can see this is the case of patient is having symptoms like fever, thirst, and restlessness. And these are the remedies provided: aconite with the prior probability as 0.3, belladonna 0.4, and arsenicum album, that is 0.3. Please remember, this prior probability says about out of certain number of patients, how many of them are used aconite, that is 0.3. How many they are employed with belladonna, that is 0.4. And arsenicum is 0.3. For example, if I have 10 patients, 3 of them are given as aconite, 4 of them are given as belladonna, and 3 of them are given as arsenicum. That's why these probabilities are coming. And this is actually the symptom: fever, thirst, and restlessness. These gives, for example, 0.8 for aconite. It means that if someone is having fever, what is the score of good answer? If I employ aconite to that particular patient having fever, 0.8 is the success probability. 0.9 is the success probability for fever if belladonna is injected. 0.7 is the success probability if arsenicum album is given. This is same for thirst. This is for restlessness. So using that concept, once again, we are having finally deciding which is having the highest probability out of it. And using the conditional probability net-based approach, we can see arsenicum album is the corresponding answer where we have the highest probability, just using the similar concept. So I just come to the conclusion. These are the future directions. What should we have? Because these are the some examples what I try to provide, and no's and yes, some of the warnings I try to provide also. But let us try to capture what can be the future direction. First of all, we have to create a large data set, because I have seen in the Ayush also, 3 crore might not be enough, because we are not looking for the number of people. I can be in different groups. If I have a problem in my heart, I am identified in one group. If I am having some problem in the blood pressure, I am identified in that group of blood pressure also. If I'm having some cholesterol, I'm identified in that group of cholesterol having people also. So it means that if I have, say, 3 crores of number, which is available in the Ayush, or more than that, 5 crores, whatever it be, it is not sufficient, because we are having the population something about 1.45 billion at this moment. So 1.445 billion people. Out of them, if I believe at least 70 to 60% of the people are having at least one disease. Some of them, some 10 or 20% having 2 or 3 diseases. So if I try to figure out all of them, the number should be some crores. It may be something 100 crores or 1 billion or maybe more than that one. That is why the data set is still not sufficient to understand every such aspect. It's to be developed more. So this is one particular thing. Second is natural language processing. We have to generate a particular logical reasoning from the sentences, what the particular texts are available. We have to create a mathematical modeling so that one can sequentially understand. Suppose someone is providing a case history, how the remedies are taken, how the steps are done. On the basis of that one, we have to create a mathematical modeling. This is called natural language processing. This can be somehow articulated using any GPT, generative pre-processing models, training models, but you have to also, human invention is required, because you can understand in a better manner other than the AI, so that things are to be cross-verified, whether the sequential measurement given by the AI chart, whether it is true, or you have to put some more particular things there, input something, enhance the matter, enhance the quality. That is also a requirement. Third is, you have to personalized treatment models, because that is the main thing. I have tried to provide some patterns, the patient charts, etc. If you have a large data set, what should be the particular remedy to be provided for a patient? For example, suppose in one patient, the values are 7, 6 today. For other day, I do have the values as 5 and 7. So that same medicine, what is being injected to me in some day, that should be changed, or 2 different persons are having same particular values of 2 different criteria. They might not be actually given the same remedy. We have to personalize the matter using some other concepts of human particular characteristic and other particular attributes which are very characteristic of that particular person. That we have to understand. Reinforcement learning, I already have said that about. That is the choice of what is the best remedy using the reward and punishment technique. They have to understand. So the potency and remedy, these are to be used over time. That can be understood properly. Graph model remedies perhaps because you are having some networks of different patients with different diseases. So there is a connection in between. Some graph technique can be understood. Network issues like in the Facebook or in social network in Twitter, what the network graphs we have, that kind of network model may be used here also to identify the cases. Integration with physiological data. That is the most important thing. Combining subjective symptoms with wearable and biomedical data. That is the most important aspect. And creating adaptive repertories that learn from clinical outcomes. The learning should be very continuous. Sometimes we require that repository. That is the most important thing also. And finally, scientific validation. Using ML for evidence-based evaluation of homeopathic treatments. That is also a piece of future argument. So I think I have done. So this is some small acknowledgement in some cases of these clustering and the cases of KNN, that is the K-nearest neighbor. I have used some of the slides that was actually created by one of my thesis student, Dr. Gautam Bhattacharya, and he was my scholar while he was doing the PhD. I have taken some of the slides from him for the KNN, and he was a summer internship project intern, Shavnik Dotto, from one college, Varashat Government College. He came to me last year for this project, and I have used some of the slides for his case also, Shavnik Dotto's case, in the case of what are the clustering techniques and etc. etc. So this is the acknowledgement. What should I actually say and finalize? So thank you everyone for your very wonderful cooperation, and I will be happy if you have any question. I will try to provide the answer. Thanks. And the online mode also, if anyone has having any question, you may ask.
Any questions from the house as well as online audience? Anyone from online audience, do you have any questions? Anything to say? Questions?
If anyone has any question, you may ask me, please. If there is, of course, may not be always. It's okay then. There is no question. Okay.
So thank you, Dr. Kaushik Ghosh, sir, for your insightful lecture on machine learning, machine intelligence. Your clear explanation and deep expertise made complex concepts accessible and engaging. Especially your lucid discussion on regression equations, K-mean clustering, and we would like...
No, I'm not touched the hypocrisy.
Maybe bias.
And thank you for your suggestions regarding future scope of research in homeopathy. And it helped us better understand the practical relevance. And we truly appreciate your valuable contribution and the knowledge you have shared with us today. May I now request our principal, sir, Dr. Shubhashish Ganguly, to come forward and felicitate Dr. Kaushik Ghosh as a token of our respect and appreciation.
Sir,
Also, I'd like to invite Dr. Shubhamay Ghosh and Dr. Shangita ma'am.
সঙ্গীতা এসো প্রমোদ চলে এসো
I'd welcome Dr. Pramod sir as well.
ঠিক আছে ও